All right, this is quiz 2 for Physics 101 3T, Fall 2013. A vector of magnitude 3 cannot be added to a vector of magnitude 4 so that the magnitude of the resultant is which of these? Well, a vector of magnitude 3 can be added to a vector of magnitude 4 in a couple of different ways. You can add it in this way, 3 and 4, and then you get a vector with magnitude 7. Or you can add it up in this way, 3 and then 4, and then you add those up and you get a magnitude of a vector of magnitude 1. So the only possible solutions have to be between 1 and 7 units long. And so all these are between 1 and 7 except for B. So B is the right answer. A vector in the xy plane has a magnitude of 25 meters and an x component of 12 meters. What is the angle that it makes with the positive x-axis? All right, so the magnitude is 25 meters. This is the x component is 12 meters. I want to know what is this angle. All right, I have the adjacent side and the hypotenuse, so I'd say the cosine of theta equals 12 over 25. That's adjacent over hypotenuse. Theta then is the inverse cosine of 12 over 25, which is 61 degrees. So the answer is C. Identical guns fire bullets horizontally at the same speed from the same height, one on the Earth and one on the Moon. Which of these is the following statements is true? Well, on the Earth, the path is going to look like this, a parabolic path. On the Moon, this is the Earth. On the Moon, it's going to look very similar, except it's going to fall at a slower rate because the acceleration due to gravity on the Moon is slower. All right, so let's see. So obviously 1 is correct. It falls at a slower rate, so it has more time in the air, so it gets more horizontal range. The flight time is less for the bullet on the Earth. Okay, that's true as well. And the velocity of the bullets at impact are the same. Because the Moon has a lower acceleration due to gravity, then that is not going to be the case. They fall through the same y range of motion, but on the Moon it has a lower acceleration due to gravity, so 3 is not going to be true because at the bottom it's going to have a lower velocity in the y direction, whereas here on the Earth it will have a larger velocity in the y direction. All right, so the answer then is 1 and 2 only. B is number 3. All right, following two vectors, what is B minus A? I already have B written here, and now minus A, look, well, let me see, that's not exactly right. Minus A is just the opposite of A, looks like that. And so B minus A will give us a vector that looks like that. So that is option C. Airplane is in level flight at an altitude of a ½ kilometer and speed of 42 meters per second. What distance does it release this bomb from in order to land right there at distance D to hit that target? Well, first of all, we want to find the time. To find the time, we say y is equal to v naught yt plus 1/2 ayt squared. V naught y is 0. Y is 500 meters. Actually, it's negative 500. 1/2 of negative 10, that's my g, and it's t squared. So this is 500 over 5, which is 100. So t is equal to 10 seconds. And then if I want to find the x range, I just say v naught x times t, because the acceleration in the x direction is 0. So that's going to be 42 meters per second times 10 seconds, or 420 meters, which is d. A stone is thrown horizontally and follows the path xyz shown. The direction of the acceleration at point y is which of these? The acceleration is always downward. All right, so at point y, the acceleration is given by the vector c. If we know an object is moving at a constant velocity, which of these can we assume? If it's moving at a constant velocity, it might be that there are forces acting on it, but there's no net force. So there could be forces, but the sum of the forces would equal 0. If it's moving at a constant velocity, it's not accelerating, and I don't know, why would it be losing mass? That doesn't make sense. So B is number 7. A 7-kilogram bowling ball experiences a net force of 5 newtons. What will be its acceleration? All right, simple, F equals ma. 5 newtons equals 7 kilograms times A. So A is equal to 5 divided by 7, which is 0.71 for number 8. 2 ropes are attached to a 40-kilogram object. The first applies a force of 25 and the second 40 newtons. If they pull in opposite directions, what is the magnitude of the resultant acceleration? So I have 40 newtons in this direction. I have 25 newtons in that direction. That means I get a net force of 15 newtons, 40 minus 25. And then F equals ma. My net force is 15 newtons. My mass is 40 kilograms. So my acceleration is 15 over 40, 3 over 8. Which is 0.38. Right. Yeah, 0.38. What can you say about the force of gravity acting on a feather or a stone? Well, the force of gravity is bigger for a stone because the stone weighs more. So A. It's not true. They have the same acceleration due to gravity, but not the same force. You step on the accelerator of your car and in 10 seconds it increases from 10 to 30 meters per second. What force is exerted to produce this acceleration? All right, we first need to find the acceleration. V is equal to V naught plus AT. 30 equals 10 plus A times 10. This 30 is the final velocity. This is my initial velocity, A, and that's my time. So that's 20 over 10. A is equal to 2 meters per second squared. And I want to know what force it is. F equals ma. It's 1,000 times 2, or 2,000 newtons. C is the answer for number 11. 2 forces act on a 6-kilogram object. One is 10 newtons. The object accelerates at 2 meters per second squared. What is the greatest possible magnitude of the other force? All right. I can find the net force. I have 2 meters per second squared. Excuse me. On a 6-kilogram object. So my net force, which is mass times acceleration, is going to be 12 newtons. All right, that means that either there are two extremes. I have one 10 Newton force. I need a net force of 12 newtons. Either I have an additional 2 newtons, or I have 22 newtons, which gives me a net force of 12 newtons. So 22 is bigger than 2, so B is the right answer. The inertia of a body tends to cause a body to resist change in motion. That's how we define inertia. This figure shows an elevator is accelerating upward at 10 meters per second squared. 10 kilogram mass hangs by a rope inside the elevator. What is the tension in the rope? All right, let's first just label our forces. That's the force tension. This is my force weight. I say the sum of the forces equals ma. I'm looking for the tension. That's force weight plus ma. It's 10 kilograms times 10 meters per second squared. That's the acceleration due to gravity, plus 10 kilograms times 10 meters per second squared. That is this acceleration. So that's 200 newtons. So B is number 14. That's your answers.